Class example 4.42. For each of the following functions, use an algebraic process to determine each of the following characteristics. So to determine some of our characteristics, it's going to be helpful to have this written in factored form. So you probably see what the problem is. We need to factor our denominator. So let's do that first. So I'm just going to rewrite this again as 2x squared plus 5x minus 12. And then we are looking for numbers that multiply to 2 times negative 12. So numbers that multiply to negative 24. And the numbers also need to add to our middle term. So they need to add to 5. So what are these numbers? Well, probably 8 and 3. And then they need to multiply to negative 24 and add to 5. So then this will have to be positive 8 and negative 3. So now we're going to rewrite this with those two numbers. So this would be 2x squared plus 8x minus 3x minus 12. And then we'll factor these first two on their own. So then we have 2x, start a bracket, and then we have x plus 4. And then for the second two terms, or for the last two terms rather, then what's common to those? Well, negative 3 is, so we'll factor out negative 3. And then we have x, negative 12 divided by that negative 3 becomes x plus 4. So our factors here are x plus 4 and 2x minus 3. So now let's write out our function again just with our factors instead. So we'll write this as f of x is equal to negative 3x over x plus 4 times 2x minus 3. All right, so now it's asking for the vertical asymptotes. So the vertical asymptotes we can actually see from looking at the denominator. So in the first one here, this would really be at x is equal to negative 4. Now this one, 2x minus 3, maybe you can figure that one out in your head, maybe not, but what you might like to do is just make yourself a little equation. So you could say 2x minus 3, where is that equal to 0? And then we can solve for x. So in this case, this would happen when x is equal to 3 over 2, or 1.5. So let's draw those in. So we should have two vertical asymptotes at those values. So at x is equal to negative 4 and x is equal to 3 over 2. Now from here, you might want to use your graphing calculator to help sketch the way this graph looks, because they get a little bit more complex than they did in the last lesson. So if you do that, you should see that we get a graph that looks something like this. All right, so from there, let's figure out our horizontal asymptotes. So the horizontal asymptote here is going to be at, well, you can see from the graph that it would be at y is equal to 0 for the HA. Now, it's not just from the graph though, we can see that from the equation. The degree of the denominator is higher than the degree of the numerator, and we can see that in either form. The x-intercept, so the x-intercept here, from the graph we can see is 0, and that actually makes sense with our function as well. So if I'm looking up here, then where is negative 3x equal to 0? Well, you could do the algebra here and divide both sides by negative 3, but 0 divided by negative 3 is still 0. So it's going to be x is equal to 0. But we kind of knew that just by looking at it, didn't we? This wasn't actually written as like x plus something or x minus something. It was just x. So in that case, it would just be 0. So that one made sense for us. For the y-intercept, we're going to throw 0 in for x and then see what we get out for y. And this one's going to be kind of funny, because if we use our we'll use our original. Doesn't really matter which one we use. So we'll write in f of x. Actually, we'll write in f of 0. I'll just throw 0 in right now. Is equal to negative 3 times 0 over 2 times 0 squared plus 5 times 0 minus 12. Well, none of that stuff in the denominator mattered because in the numerator it was 0. So everything became 0, which also makes sense, where a y-intercept would also be at 0. That's why we're going through the origin there. So that's going to be at 0. So we'll have our point labeled 0, 0 for the x-intercept and the y-intercept. Okay, the domain here. Well, again, the domain is going to be really determined by our vertical asymptotes. So that's going to be at, so we'll say x such that x cannot equal negative 4 or 3 over 2. And now the y-intercept, or the range, sorry, would be, well, anything. That actually any value of y is allowed because we cross the horizontal asymptote here. So it's not going to be excluding just the y is equal to 0. Our range would just be y such that y is an element of the real numbers.